Hello everyone, welcome again to iTTV, and you are with me, your tutor for this lesson, Mr. Joel. Alright, remember there are only 3 types of variations that are in this chapter, and every time you hear the word variation, it simply means that you're actually checking out the relationship between how many variables? 2 variables. Alright, so we have studied the first one, which is called direct variation. Before we go into the next kind of variation, which is called inverse variations, let us take a quick look back about direct variation. So remember, let's take a look. For example, the pressure in a pressure cooker varies directly as its temperature. If the pressure in the device at 150 degrees Celsius is 120 kPa, what is the pressure in the cooker at 180 degrees? So guys, taking a look here, remember when you see a question, try to understand, alright? It's direct variation. What are the 2 quantities involved here? First of all, you have pressure, right? So denote it with P. And next, temperature. So if the symbol is not given, you represent yourself, alright? T for temperature. So now, let us answer this question. Step 1, write the equation always. So P equals KT. And what is K? K is the constant of proportionality. Alright, so remember 2 ways to write it down, either symbol form or equation form. Step 2, find the value of K. P equals KT. 120 equals K multiplied by 150. K equals 4/5. Alright guys, usually to find the value of K, you would need to substitute a pair of values for the variables involved, and it always will be given. Alright, when you get back the K, don't forget to insert back so that your equation becomes complete. And finally, step 3, find the value of P. So P equals to 4/5T at 180 degrees Celsius. P equals to 4/5 multiplied by 180 degrees Celsius. The pressure is 144 kilopascals. Alright, so remember, direct variation, one quantity increases, the other will follow. One decreases, the other will also decrease. So remember the pattern of change, alright, between the 2 variables. Now, take a look at this picture. We are starting off with inverse variation. What can you see there? Melting ice, right guys? So what happens? What can we make out of melting ice if we want to relate it to an inverse variation? Let's take a look. The longer the time, T, it is exposed to the environment, smaller is the ice, S. So 2 quantities are here. First of all, time, right? And then next will be the size of the ice, or S. So what is the relationship? The longer the time you leave it outside, what happens? The size becomes smaller. So can you see that actually there's an inverse pattern happening here? More time, less the size of the ice it becomes. So what can we make of this relationship? S varies 1/T, or S equals K/T. So now let's take a look at another example. Alright, what can we see here? There are 2 containers, right? And what is the arrow pointing downwards represent? So take a look at the first one. I can guess that it is compression. So the first one, more compression. Next one, less compression. So remember, inverse variation, 2 variables still involved, but the pattern is now in the opposite direction. The greater the compression pressure, P, the smaller the volume, V, of the container. So V varies inversely as P. V equals K/P. So remember now, the more you compress, the less the volume, right? Because the volume will be squeezed. So remember, that is inverse. The less the compression, the more the volume. So remember, there is something like less, more, or more, less. Alright, if you compare it to direct variation, more, more, less, less. So that is the pattern, guys, of inverse variation. So let's take a look now at the constant of proportionality K when it comes to inverse variations. So y varies inversely as x, or y varies 1 over x, y equals k over x. When the value of y increases, the value of x decreases. So same thing now, when the value of y decreases, the value of x increases. So xy equals to k. K is the constant of proportionality for inverse variation. When k equals xy, y varies inversely as x. When k does not equal to xy, y does not vary inversely as x. Alright guys, it's the same as direct variation. I'm going to show you again, alright, on the board, what is the pattern of inverse variation. Alright, so pay attention. Alright guys, if y varies inversely as x, alright, so remember, take a look at the keyword. The keyword here is inversely. So you know that the two variables are y and x, and remember they can be anything, alright. The x can be x squared, x cubed, square root x, right, as long as you can recognize any two single quantities. So now because inverse variation is mentioned, you know that when y increases, x will decrease. When y decreases, x will increase. So they are inverse to one another. So when y varies inversely as x, now take a look. We have to use the same symbol. Remember, the fish, right, is the symbol for variation. So write down this. Y varies, and this symbol simply means varies. Alright, inversely you must always start with 1 over the other quantity. So when you see this, it means that y varies inversely as x. This is enough to tell you the pattern of inverse variation. And same thing, this is in what kind of form? Symbol form. So remember, symbol form is here. Symbol form, or I call it the variation form. And it can be changed to the equation form. When you replace the symbol with equation, don't forget you must multiply the other quantity with k, which is the constant of proportionality. So when you multiply inside, it also gives you k over x. And this, guys, is the equation form. So there are two forms here for any kind of variation, alright? We have studied direct variation, we have now studied inverse variation. So the most important thing is this and this. Remember guys, they are the same thing, just in different forms. Alright, let's take a look at this example. The number of days, D, to complete a task in a construction site in relation with the number of workers, W, working is shown in the table below. So number of workers, 50 workers, you take 5 days to complete. 100 workers, 4 days. 150 workers, 3 days. 200 workers, 2 days. 250 workers, just a single day. Alright guys, be very careful. Doesn't mean that the number of workers increase and the number of days decrease. This is inverse variation because you need to verify it. And every time you need to verify any form of variation, whether direct or inverse, you need to use the value of k. So remember now, because y equals to k over x in an inverse variation, the value of k is actually the product of x and y. In this case, D and W. Determine whether the number of workers varies inversely as the number of days. So now, determine whether W varies inversely as the number of days. So for inverse variation, K equals WD. Alright, K equals WD is an equation that is formed, alright, from the equation form of the inverse variation. So add one extra row, K, which is the product of W and D, and find the product. Alright, 50 times 5, 250, 100 times 4, 400, 150 times 3, 450, 200 times 2, 400, 250 times 1, 250. Are they the same, guys, for all the number of days and the number of workers? No, right? Because all of them are different. This means that the constant is not existing. So the conclusion is, since K does not equal WD, this is not an inverse variation. So although a pattern is there, inverse variation doesn't occur. Because if inverse variation is there, the value of K that is obtained would be equal for all the pairs of values of W and D. Alright, now, some examples of inverse variations are shown in the table below. So take a look at this table. The first relation is y varies inversely as x. And remember, symbol form, y varies 1 over x. 1 over must always be there to denote inverse variation. Equation form, y equals k over x. And where does that k come from? Every time you change it to equation form, you multiply k, which is a number that you are about to find, with that other quantity. Alright? Y varies inversely as x squared. Y varies 1 over x squared in symbol form. Equation form, y equals k over x squared. Y varies inversely as x cubed. So symbol form, y varies 1 over x cubed. Equation form, y equals to k over x cubed. Y varies inversely as square root x. Symbol form, y varies 1 over square root x. Equation form, y equals k over square root x. So guys, look at this table again, and can you identify a pattern? No matter what the quantities are, always in symbol form and equation form, it will take this kind of pattern. Alright guys, let's take a look at an example now, right? Given that y varies inversely as x minus 2 and y equals 0.6 when x equals 7, express y in terms of x. Let's move on to the board to solve this question. Alright guys, it is given y varies inversely as x minus 2. Alright, now, inverse variation is there. What are the two quantities? First of all, y, next, x minus 2. Right? So I know that, remember now, the quantity can be anything in terms of x. Alright, it's a function. So in this case, when y increases, x minus 2 will decrease, and vice versa. So now y is 0.6 when x is 7, express, right? Y in terms of x. Every time you are asked to express y in terms of x, remember, you are about to find an equation. So remember, first of all, step 1, write down using the symbol form. So y varies, so the variation symbol inversely must always be 1 over x minus 2. This is enough to tell you the inverse variation is about to occur. Next step, remember, because we are about to find an equation, convert it to equation form by changing the symbol. But every time you change to equation form, multiply 1 over x minus 2 in this case with k, which is the constant of proportion. And before you can find the equation of y in terms of x, you must always find the value of k. And that is step 3, guys. How are you going to find k? By substituting given values of y and x. When y is 0.6, it is given from the question, x is 7. So 1 over 7 minus 2. So we can simplify. 0.6 equals to 1 over 5. Now, k is 0.6 multiplied by 5, which is 3. And remember guys, k must always be inserted back inside the equation, because your equation is not complete unless you find the value of k. So now, since we know k is equals to 3, we can say that y equals to 3 over x minus 2. And this is the equation relating y to x. Alright, let's take a look at an objective question. T varies inversely as the square of v. Given that the constant is m, find the relation between t and v. A, t equals v square over m. B, t equals 1 over mv square. C, t equals m over v. D, t equals m over v square. Alright guys, I'm going to leave it to you to try to attempt this question. Alright, what are the two quantities? T and v square, right? And what kind of variation? Inverse variation. So remember, step 1, always write it in symbol form. T varies 1 over v square. Change it to equation form, and the constant is not k here because they told you specifically we are representing it with another letter m. So t equals m over v square. Your answer is D. Alright, next example. It is given that D is inversely proportional to square root c. If D equals negative half when c equals 4, the equation which relates c to D is A, D equals 1 over square root c. B, D equals negative 1 over square root c. C, D equals 2 over square root c. Or D, D equals negative 2 over square root c. Alright guys, what is the right answer? Let's go to the board. Alright, now we have a question on inverse variation. And always remember, identify what are the two quantities. First of all, it is D. Secondly, it is square root c. Remember, these are the two quantities. So whatever quantity is mentioned first, it will be on the left hand side. So D varies inversely as c. This is confirmed. So D, symbol 1 over square root c. Alright, because that is important. Now, what do you want? You want to change it to an equation, right? So you must change it to equation symbol by changing it to equation. And every time you want to change the equation, multiply k with this whole thing. So immediately k over square root c. The equation is not complete unless you find k. And remember guys, to find this value of k, you always need a pair of values, and the question will always provide you there. Because when D is minus half, C must be 4. So replace D with minus half. And C will be 4, so square root of 4. So now let us just simplify it. So K square root of 4 is 2, and the value of K is actually negative half multiplied by 2, which is negative 1. And remember guys, what do you do with this value of k? You have to substitute back inside the equation. So now, since k is negative 1, so D equals k, which is negative 1 over square root c. So your equation is complete when the value of k has been known and put back inside the equation. So I'm sure you have an answer there. The answer is B. Alright, now let's take a look at this example. The table below shows some values of the variables h and k such that h varies inversely as the cube root of e. So h4 e27, h6 e8. Alright, let's take a look at the next part. Find the relation between h and e. A, h equals 2 over cube root e. B, h equals 12 over cube root e. C, h equals negative 2 over cube root e. Or D, h equals negative 12 over cube root e. Alright guys, remember, okay, what we have discussed, the steps. Alright, can you try this yourself? We'll be back to see what is the answer. Alright, let's take a look at the solution. Remember, always the same 3 or 4 steps. First of all, always write it in the symbol form or the fish form. Alright, after you have identified both variables. And be careful of the word cube, cube root, square or square root, alright? Because sometimes the function is in a different form. Next, change it to equation form by putting k. Find k by substituting values. Put back the k inside and see whether you want to use it to solve other problems. So now, h varies inversely as cube root e. Change it to equation. H equals k over cube root e. Substitute values. 4 equals k over cube root 27. 4 equals to k over 3. Value of k is 12. Therefore, k equals 12 over cube root e. So you can use any of those two values and they will give you the same value of k. So now the answer is B. H equals 12 over cube root e. Alright, now, given that y varies inversely as x and y equals 2 when x equals 4, find A, the value of y when x equals 2, B, the value of x when y equals negative half. So guys, this is another case of inverse variation. Remember, the steps are always the same, alright? So organize your working carefully, alright? Let us go through this one by one. The solution, it is given y varies inversely as x, so y vary 1 over x. Y equals to k over x. 2 equals k over 4. K equals 8. So A, y equals 8 over x. Y equals 8 over 2. And the value of y equals 4. B, y equals 8 over x. When y equals negative half, equate it to 8 over x. X equals 8 divided by negative half, which is 8 times negative 2 over 1. The value of x is negative 16. So remember guys, if you are about to find an equation involving the two variables or solving some problems, for example, finding y when x is this or finding x when y is that, remember you must always start with the same thing, alright? Write the variation form, write equation form, find k. Alright, next example. Given that r varies inversely as t cubed and that r equals 2 over 9 when t equals 3, calculate the value of r when t equals 2. Is it A, negative 2, B, half, C, a quarter, or D, 3 quarters? So guys, remember this, alright? What are the two quantities? R and t cubed. So the pattern of variation is inverse. So remember to start off with the same thing, alright? So let's go through this together. So r varies inversely as t cubed, write it in symbol form. R equals k over t cubed, which is equation form. 2 over 9 equals k over 3 cubed. 2 over 9 equals k over 27. K is 2 over 9 multiplied by 27. The value of k is 6. So substitute back the value of k inside the equation. You will get r equals 6 over t cubed. So r equals 6 over 2 cubed. R equals 6 over 8. The value of r is 3 quarter. Alright guys, let's take a quick review now since we have ended this lesson. Alright, what have we learned today? The second type of variation, which is called inverse variation. Alright, as the name suggests, you know that the pattern of change is always inverse of one another. So a few quick properties. 1, determine whether a quantity varies inversely as another quantity. We have learned that. Alright, how do you determine? By identifying the constant k. 2, write the relationship between two variables in equation form. 3, understand that if y varies inversely as x, then y varies 1 over x. In equation form, y equals k over x, where k is a constant. And you can get k by multiplying x and y. And lastly, understand that if y varies inversely as x to the power of n, then y varies as 1 over x to the power of n. So guys, with that concludes this lesson. Alright, remember we have still one more kind of variation to go and we will be looking at that in the next lesson. Alright, so see you then.